Hi everyone, welcome to Abel's Calculus. In this video, we will be reviewing exponent rules and radicals for SAT Math. So far, we have reviewed angles, exponential functions, trigonometry, triangles, straight lines, quadratics, and circles. Now, before we begin, I wanted to let you know that I have created an SAT Math course, which is completely free, and you can get it in the description box of this video. And also, I have created a formula sheet. This is the formula sheet, the one that I'm sharing to record the videos. You can also get its PDF file in the description box. I hope it will be helpful for you. So let's get started with the exponent rules. Okay, so on the left-hand side, we have these rules. If you have x raised to a and x raised to b, that means if the base is same and the exponents are different, so and these powers are multiplied, then you add the exponent. Okay, that means if let's say if you have x square times x raised to 5, okay, so the base is same, so you'll add the exponent, so 2 plus 5 becomes 7. Then if the powers are divided, in that case, you will subtract the exponent. So here, if you have x raised to 2 divided by x raised to 5, or if you have something like this, x squared over x raised to 5. So you subtract the exponent. So 2 minus 5 is -3, so x raised to -3. And x raised to -3 is nothing but 1 over x cubed. You will get 1 over x cubed from this expression. Then then the third one is called power of power. So you have x raised to a, and then this entire power is raised to b. In this case, you just multiply the two exponents. So it becomes x raised to a times b. The fourth rule is the negative exponent rule. If you ever have a negative exponent, so x is the base, and it is raised to -a. So the first thing that you have to do is you have to make the exponent positive. And in order to make the exponent positive, you have to take the reciprocal of the base. So the base is x. Base is x. So reciprocal of x will be 1 over x. Okay, so the moment you take the reciprocal, the exponent becomes positive. So a similar rule is this. Instead of x, we have x over y. We have a fraction, and the exponent is negative. So if you want to make the exponent positive, you'll have to take the reciprocal of the base. So this time the base is x over y. And if you take the reciprocal of x over y, you'll get y over x. And the exponent will become positive. The next rule is the zero exponent rule. Now, anything raised to 0 gives us 1. So this x can be anything. Like you can literally have anything. Let's say 5 over 11 raised to 0. That will be 1. Anything raised to 0 will be 1. The next rule is actually helpful when you have to solve exponential equations. So if you have something raised to exponent a, so let's say x raised to a is equal to x raised to b. Okay, so when bases are same, here the base is x and here the base is x. In that case, you can equate the exponents. So you can equate the exponents. Okay, for example, if you have, let's say, 5 raised to 2x is equal to 125 raised to x. Okay, and you have to solve this equation. You have to solve this equation. So what you'll try to do, this is an exponential equation. And this is an exponential equation because you have variable in the exponent. So what you'll do, you'll try to make the bases same. So here the base is 5, here the base is 125. And you know that 125 can be written as 5 raised to 3. So this is the equation. And if you apply the power rule, you'll get 5 raised to 3x. So 5 raised to 2x is equal to 5 raised to 3x. Now the bases are same. Base is 5, base is 5. So you can equate the exponents. So you can equate the exponents. So 2x is equal to 3x. And in this case, you'll get no solution. Because if you divide by x, you'll get 2 is equal to 3. Well, that is false. So in this case, you get no solution. But this is how you have to solve an exponential equation. Next, you have radicals. Radicals are actually nothing but when you have fractional exponents, like x raised to 1/2, x raised to 1/3, x raised to 1/4. These are fractional exponents, and these are actually nothing but roots. So x raised to 1/2 can be written as square root of x. X raised to 1/3 can be written as cube root of x. X raised to 1/4 can be written as fourth root of x, and so on. So here, if you see, you have x raised to a, and this is inside the bth root. So this b means this is bth root. B can be anything. Okay. So what you have to do is, if you have to simplify this kind of expression, what you will do is, this will become a radical. So you'll have a fractional exponent with this number being in the numerator, and this number will become the denominator. So you get x raised to a over b. B will go in the denominator because of this. So if you have nth root, of x, this is actually x raised to 1 over n. Okay, that's why b goes in the denominator. And you can also write it like this: bth root and this entire thing raised to a. Okay, now these three rules are really important. If you first take square root of something and then you square it, so basically you're actually doing, so basically the square root and square will get cancelled and you'll get x. So it's like if you have x and first you're dividing it by 2 and then you're multiplying it by 2, so eventually you will get x, right? So it's the same thing that's happening here. First we're taking the cube root and then we are cubing it, so you'll end up getting the same thing. This and this will get cancelled. So in general, if you're taking nth root of something and then you raise it to power n, then the root and the power will get cancelled and you'll end up getting the same thing. So that's it about exponent rules and radicals for SAT Math. And if you found this video helpful, please don't forget to subscribe to my channel. That really gives me motivation to keep coming up with the new videos with other helpful resources. So thank you so much for your time. I'll see you in the next video.